Now that we've found m and n, we can go ahead now and find k. So what I've done is I've rewritten our rate equation and I've substituted in the values for m and n that we found. Now we can go ahead and find k. We'll also go ahead and find the overall order of the reaction as well. I'll do that at the end. Alright, in finding k, what we can do is recognize that k is going to be the same for any experiment that we choose here. It's going to be close. It might not be exactly the same, but it'll certainly be in the ballpark. So it doesn't really matter which experiment I choose to substitute values in. So if I just go ahead and choose experiment 1, it's just a matter of then throwing in these values and then calculating k and isolating it. So let's see what we can do here. We've got a rate that's going to be 1.80 times 10 to the negative 5. And the units of k will also be important, so I'm going to include units in my calculation as well. So we've got HgCl2, that's going to be 0.105, 0.105 molar to the power of 1, and 0.150 molar to the power of 2. So as you can see, what's going to happen is I'll isolate k, and k will be 1.80 times 10 to the negative 5 molar per minute over 0.105 molar, that's all going to be the first power, and this will be 0.150 squared molar squared, because I have to distribute the squared amongst the unit and the number, of course. So what we're going to end up with here, once I throw all that in, is I'm going to end up with 7.61 or 7.62 times 10 to the negative 3. And the units on that will be, well, these will cancel, and we'll end up with m to the negative 2 minutes to the minus 1. Now the reason it's m to the negative 2 is because the m squared is on the bottom, and whenever a power is on the bottom it always turns into a negative. So that's how we can get the units of k. So it's m to the negative 2, and that was per minute to begin with, so it's m to the negative 2 per minute. That'll be the units on little k over here. Now to get the overall order, the overall is just going to be the sum of the orders. So overall order for the reaction is going to be m plus n, which is 1 plus 2, which equals 3. So when we combine the effects on the concentration in the total reaction, it comes out to be a value of 3. So the overall order is 3, but the order with respect to each of these is 1 and 2 respectively.